In this video, I introduce a facial vector as a face image descriptor. Facial vector is a patch aggregation mechanism based on the facial kernel. The facial kernel combines the generative and discriminative methods to face classification by driving a kernel from a generative model of the data. The generative Gaussian mixture model is used as an image visual vocabulary. This pipeline of facial vector for face classification. Suppose that X is a sample of T observations xt. U lambda is a probability density function, which models the generative process of elements in X, where lambda denotes the vector of M parameters of U lambda. The single function G lambda X is defined as a gradient of the log likelihood of the data X here, which describes the contribution of individual parameters to the generative process. Facial kernel is used to compare two images X, Y, which is defined as here. Where F lambda is a facial information matrix that is defined as expectation with respect to X. Since F lambda and his inverse are positive semi-definite, using the Pulaski decomposition, the inverse F lambda is equal to transpose the L lambda by L lambda. The facial kernel can be rewritten as here, where G lambda X is a facial vector of X, which makes the facial kernel computation easier. Suppose that X is a set of d-dimensional local descriptors that are extracted from an image, and the samples are independent. Facial vector G lambda X is written as here. L lambda is the square root of the inverse of a facial information matrix, and U lambda is a Gaussian mixture model. We choose U lambda as a Gaussian mixture model since GMM can approximate any continuous distribution. Suppose that lambda is a parameters of a key component GMM, where WK is a weight, mu k is a mean vector, and sigma k is a covariance matrix of Gaussian key. So we have this U lambda is a weighted sum, where WK is a softmax function, where UK corresponds to a Gaussian key. The GMM parameters are estimated on the training set of descriptors to optimize the maximum likelihood criterion. Using gamma lambda here, gradient of xt with respect to lambda or derivative of gamma lambda with respect to alpha k, mu k, and sigma k, where gamma d is a soft assignment of xt to Gaussian key, which is a posterior probability here. We use this process to calculate facial vector that is used for face classification. For more details, please check with these references. Thank you. Bye.